Hello everyone. First and foremost, I would like to thank Department of Physics, Namchi Government College for providing us a opportunity to make YouTube video instead of practical examination for sessional 2 of 25 marks. Furthermore, we thank our teacher Dr. Sikha sir for providing us topic and for his guidance. My name is Sikha Prasad and my roll number is 19NS0089. I am a student of Physics Honours 4th semester 2021 and I have been provided with the topic Lagrangian formulation. So starting, I will give the introduction to this topic. So far, we have seen that based on Newton's laws, one can formulate a description of motion that is based solely on the concept of energy. A lot of research was done in the 18th century to reformulate a theory of mechanics that would be equivalent to Newton's theory, but whose starting point is the concept of energy instead of the concept of force. This modern approach to classical mechanics is primarily based on the Lagrange and Hamilton. So, what does this Lagrangian formulation says is let us talk about the topic degrees of freedom. Here, the number of independent ways in which a mechanical system can move or change its configuration without velocity, any constraint which may be imposed is called number of degrees of freedom of the system. So here the minimum number of independent variables needed to describe the complete configuration of the system. Let us suppose for an example we consider a particle which is free to move in 3D space. So in this condition, if you want to describe the motion of the particle completely, we need 3 position or space coordinates x, y and z. Here, if we know these 3 space coordinate of a particle at a given time. In that condition, we may completely describe the motion of the particle. Now, if we know its complete description, if we know x, y, z, it means its position is determined, its vector is determined. So, can't express y in terms of x and z, and we can't express z in terms of x and y. So, as in this particle, the minimum number of independent variables required to describe the complete motion of that single particle is 3. The degree of freedom of the particle free to move in 3D space will be 3. Degrees as, let's write in this particle, the minimum number of independent variables required to describe the complete motion of that single particle is 3. The degree of freedom of the particle free to move in 3D space will be 3. The degree of freedom of the particle free to move in 3D space will be 3. X, Y, Z to describe the complete motion of the system. Now, if we know these variables as a function of time, x is a function of t, y is a function of t, and z is also a function of t. In that condition, we may determine component of velocity. X is equals to dx dt, y is equals to dy dt, and z is equals to dz dt. By differentiating these three variables, we got dx dt, dy dt, and dz dt, which are velocities. Now, again, if we differentiate these velocity components, we will get the components of acceleration. X double dash is equals to d2x by dt square, y double dash is equals to d2y by dt square, z double dash is equals to d2z by dt square. These are acceleration of the particle. So we say that if we know this independent variables x, y, and z for a particle moving in 3D space, we can determine the complete motion of particle. So the degree of freedom x, y, z to describe the complete motion of the system. Now, if we know these variables as a function of time, x is a function of t, y is a function of t, and z is also a function of t. In that condition, we may determine component of velocity. X is equals to dx dt, y is equals to dy dt, and z is equals to dz dt. By differentiating these three variables, we got dx dt, dy dt, and dz dt, which are velocities. Now again, if we differentiate these velocity components, we will get the components of acceleration. X double dash is equals to d2x by dt square, y double dash is equals to d2y by dt square, z double dash is equals to d2z by dt square. These are acceleration of the particle. So we say that if we know this independent variables x, y and z for a particle moving in 3D space, we can determine the complete motion of particle. So the degree of freedom of that particle will be equal to 3. Now if we consider the same particle but under a constraint, so that the particle is compelled to move along a definite path in a space, say a circle, a rectangle, or the irregular path like this or this. To describe the motion of the particle moving along the circle at any time, how many independent variables we need? So we could say 2, that is x and y, if the circle lies in x wavelength. But that's wrong. In fact, 2 variables x and y are definitely needed to describe the motion of the particle along this circular path, but in that condition x and y are not independent from one another. So here what we saw is, when a particle moves without a constraint, these variables x and y are independent of each other, but if a particle is made to move along with a constraint, these variables x and y are not independent from one another, that is x and y depend on each other. So let us take the equation of circle, that is x square plus y square is equals to a square, where x and y are position coordinates at any point of the circle and a is the radius of the circle. From this equation, if we know the value of y, we can find the value of x, and if we know the value of x, we can find the value of y. So here we conclude that therefore x and y are dependent on each other. So what we can say is, so when the particle is bound to move in a definite path we need only one independent variable to describe the motion. So what does it means is, so when the particle is bound to move in a definite path, we need only one independent variable to describe the motion, which is opposite when we didn't consider the constraint. So what we can say is, imposition of constraint reduces number of independent variables, which further reduces the equation of reduces the number of equation of motion. So what it does is, it makes the solution of the dynamical problems more convenient. For that, let us consider a system with n number of particles. Let the system be like this, with n number of particles represented. I am representing it here with the dotted dots. Here n is equals to number of particles subject to k independent constraints. Here we can also say that constraints imposed on rigid body is not independent of one another. Now, if we express the constraints in terms of the mathematical equation, we can write it as, it is written as g of x1 y1 z1 x2 y2 z2 up to xn yn zn t is equals to a1. This is for the first particle, and for second particle g2 x1 y1 z1 x2 y2 z2 up to xn y1 zn t is equals to a2, or it can be written as g1 r1 vector r2 vector up to rn vector t is equals to a1. Now it can be also written as Gj to H. Here I can be equal to 1, 2, 3 up to n, and j can be equal to 1, 2, 3 up to k. Here I is equal to number of particles and k means number of constraints. Now what we conclude is, after imposing k constraints, the degree of freedom f is equals to, so f is equals to 3n minus k.